This is Geometry, Unit 8, Day 6. This is page 655. We're looking at the different vocabs of circles. We're looking at point B. This B, there's no symbols around it, so we know it's point B. This would be point of tangency. The letter that goes with that would be letter G in your options. BH. B to H, it has the arrows, so that is a common tangent because it's touching two different circles. And with your multiple choice, that would be H. AB. AB, if we're talking about the segment AB, that would be a chord. And chord would be the multiple choice of C. AB with the arrows, that's line AB, that would be a secant. And that's multiple choice E. Line AE. Line AE is touching the circle in exactly one point. It's a line, so we would call that a tangent line. And that's your multiple choice of F. G. The single G represents the center of a circle. So center was multiple choice A. CD. CD goes from the center of the circle out to the edge of the circle, so that's called a radius. And radius was multiple choice B. And then BD, with the segment bar, goes all the way across. That's the diameter. And diameter was a multiple choice D. For number 18, we're going to look to see, is AB tangent to circle C? We're going to use the converse of the Pythagorean theorem to show that the radius is perpendicular to segment AB. So to do that, we're going to use our C squared equals A squared plus B squared. C squared being our hypotenuse, so that would be 5 squared. The A and the B are going to be the legs of our right triangle, so 3 squared and 4 squared. You may have noticed that the numbers 3, 4, 5 make a Pythagorean triple. So yes, it makes a right triangle. We showed that A squared plus B squared equals C squared. So we have CA is perpendicular to AB. So that makes AB a tangent. Circle C. There's your notation for how to represent circle C. You actually make a little circle with a dot, and then you put the letter of the center. On this side, we have our C squared equals leg squared plus leg squared. So our hypotenuse in this case is 18. 18 squared is our 324. 81, 225, so when you add together your 81 and your 225, we're going to get 306. So 324 does not equal 306. So our CB is not perpendicular to BA. AB is not tangent. So come to our last one. Now this picture is a little bit different. Notice the way when I look at the picture here, it looks like the radius is 10. So this whole side of the triangle, I believe, is going to be 10 and 10, which is 20. So we're still going to talk about the hypotenuse and the leg and the leg. So the hypotenuse of this triangle is 52. We're still trying to see, is this 90 degrees down here? So the two legs, one is going to be 20 and the other is going to be 48. So it's 52 squared, by the way. So we say 52 squared, 2,704. 20 squared is 400. 2,304. And take your 304 plus your 400 to give you 2,004 equals 2,000. Oh, it's 2,704 equals 2,704. So we're going to know that looking at our picture, they don't give a letter up there, but CB is perpendicular to AB. We'll call it BA. So AB is a tangent. For number 21 through 23, we're going to find the value of R, which is our radius. We know that we have a tangent which is perpendicular to the radius. So when we have that, we're going to take the R, which is the radius, plus the additional 16 is how much this extends out. So it's R plus 16. So it's that value squared equals the leg squared plus the other leg squared. So we're going to say R plus 16, put that in parentheses, do it again, R plus 16. You cannot distribute the exponent into a binomial. That never works, never in algebra, never in geometry. It's a common mistake. Okay, when we calculate the square of 24, we get 576. So how we multiply, this is called multiplying binomials. To do that, you're going to use a format that we often call FOIL, where you multiply the front, which is R squared, the outer, which is 16R, the inner, which is 16R. Those will always match if this is a perfect square binomial. And then 16 and 16, when we square that, we'll get our 256. Well, when we start to collect like terms, we're going to subtract the R squared across and that's helpful because that gets rid of our squares completely. That's going to leave us with 32r on this side. We'll subtract our 256. That'll leave us a 0, 2, and a 3. So when we divide by 32, we see that r is going to be 10. So the radius in this case would have to be 10, and that would be a right triangle. Let's try that again. Here we're looking at a line that is definitely tangent. It forms a right angle with the radius. That's going to happen with every tangent line. It's always perpendicular to the radius. So you take the hypotenuse, which is r plus 6 squared. That's going to equal your leg squared plus your leg squared. Well, when we do r plus 6 squared, that means to write it twice. We still have r squared, and 9 squared is 81. So we're going to FOIL this together to get r squared, 6r, plus 6r again, plus 36. This is r squared plus 81. Well, we're going to subtract the r squareds. The two 6's add together to be 12r. Then we're going to take our 81 and we're going to divide that by the 12. And we're going to get 6.75. So that just reinforces that this is not a Pythagorean triple, where this, for question number 1, or 21, when the radius came out to be 10, it was definitely a Pythagorean triple, 26, 10, and 24. But in this case, because of the decimal side, it's not a Pythagorean triple, but no big deal. It's still a radius of 6.75. So how do we set up this problem? We know that we have a tangent, so we know that it is perpendicular to the radius. We're going to take the r squared, well, just r. We're going to take the r plus the 7, and we're going to square that. And we're going to equal that to the leg squared plus the leg squared. So when we say r plus 7 squared, that means that we should write it twice. We don't need to write another square. We already had it squared. R squared's out here. 14 squared is 196. So to multiply our binomials, we need to do the front, the outer, the inner, and the last. R squared plus 196. Now we would subtract the r squareds. And that would leave us with 14r minus the 49. So when we minus that, we're going to have 196 minus the 49, which leaves us with 147. And we'll divide that, and we'll get 10.5. So our radius is 10.5. Now, when I kind of looked at this, I noticed that I subtracted my 49. That reminded me to kind of look back at number 22. Did I remember to subtract? Doesn't look like I subtracted that correctly. I didn't subtract it at all. I needed to subtract the 36 from the 81. So I'm sorry, this is not 6.7. So we have 12R. This guy crosses out completely. We have 81 minus the 36 to get 45, and we'll divide that by 12. And we'll get 3.75, not 6.75. Sorry about that. For number 37, we're looking at a satellite that is above the Earth, 11,000 miles. The Earth itself has a radius, they're calling it to be 3,959 miles. What we're supposed to find out is find BA, how far is the distance that the satellite can display out to the edge. It's 11,000 here, so this should be more than 11,000 coming out here to the edge. Well, to do that, well, it's only going to touch the Earth at exactly one point as it pushes, so it's tangent. BC and BA are tangents. So we know that tangents are supposed to be perpendicular to the radius. So we have a right triangle. We know the radius. We know the total length from the center out to B, so we're looking for the other leg. So we're going to say that the hypotenuse, which is 3,959 plus 11,000, that quantity squared is going to equal the leg, which is 3,959 squared, plus this unknown, which is BC. Well, when we add this part together, we're going to get that to come up to be 14,959, and that's squared. 3,959, and that's squared. And BC squared. Well, when we square that amount, we're going to get something huge. 223,771,681. And that's supposed to equal our 3,959 squared, which is 15,673,681, plus this unknown BC value. Well, we have to subtract our 15,673,681. Subtract that from both sides. That crosses out completely. So we're going to take our original 14,959 that's squared, that real long number, and we're going to subtract the 3,959 squared from that. And we're going to get 208,098,000, and that's our length of BC. So we have to take the square root of our answer, which comes out to be 14,425 with a little bit left over. So again, we just did Pythagorean theorem. We took the hypotenuse that was made up of two pieces. We squared that. We took the leg and squared that, subtracted that over. Then we had to take the square root to get the BC by itself. So BC is 14,425. Now if we were to do this on the other side, for AB, we're going to find out that AB is also, it's making the same exact triangle again. We have a radius of 3,959. The hypotenuse is the same, so the equation is going to come out exactly the same. So we're going to get 14,959 squared equals 3,959 squared plus AB squared. When we subtract everything over, we're going to get our values of 208,098 equaling our AB squared. So we'll have to take the square root of that value. And when we do that, we get our 14,425.6. So the point that we're supposed to recognize is if two tangents intersect outside the circle, they can't intersect inside the circle, so if they're intersecting outside the circle, then they are equidistant to the sides of the circle. Each of those tangents are the same length, and that'll be true for any set of tangents as long as they intersect.